Hi, this is Mrs. Dorman, and we are going to graph transformations of quadratic and cubic functions. Okay, so our first function is we're going to review what x squared looks like. So I'm going to make a little table and plug in numbers for x and see what we get when we square them. We want to do some negative numbers and some positive numbers. So I'm going to plug in -1, -2, -1, 0, 1, and 2, just so I have a mix of positives and negatives. So if we plug in -2, -2 squared is 4, and then I'm going to graph these as I go. -1 squared is +1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. And we could keep going. We could square 3 and get 9. We could keep getting more numbers, but this gives us enough of an idea of what x squared looks like. So the shape is a parabola. The domain of this function, the parent function, before it's been transformed or anything, and actually even after it's been transformed, the parent function, or the domain, is just all real numbers. We can plug in any number for x and square it. There's no restriction to what numbers we're allowed to plug in. The range is what are all the output values, and we're always going to get a positive number if we square it, or just 0 if we square 0. So the range is numbers from 0, and including 0, that's why I'm using the square bracket, to positive infinity. So we're going to be doing transformations. We're going to practice the transformation of f of x equals x squared. And so you are taking the function, that's what this part means. Take the function. We could have a number multiplied to the function, and that's going to give us our vertical stretch. That value multiplies the outputs. So it's either going to vertically stretch it or compress it if it's a number that's less than 1. And then there could be a number added or subtracted with the x, and that's the horizontal shift. And the reason there's a minus there is because it's the opposite. So if it's a positive number, you go to the left, and if it's a negative number, you go to the right. And then there could be a number just by itself, and that's the vertical shift. So we're going to practice one of these. Okay, so we're always going to start with identifying what the parent function is and graphing it. So I'm seeing a squared there. The parent function is just x squared. So you start with graphing that. I'm just copying the points from the parent function that we just did on the previous slide. So this is what the parent function looks like. I'm just going to make it like a dashed line because it's not our final graph. I'm just sketching what the parent function looks like. And then we want to identify a. So x squared is being multiplied by -3. A is -3. By the way, the h is 4, so that's going to be our horizontal shift, and k is 3, so that's going to be our vertical shift. So since a is -3, the way we perform that transformation with our graph is we multiply the y values, the output values for each of our points, by -3. Okay, so I'm going to switch colors, and I'm just going to do the points from left to right. So I'm going to start with -2, 4, and the y value is 4. So if we multiply 4 by -3, then it becomes -12. So instead of -2, 4, I get the point -2, -12. So it's way down here. Then I'm going to go to the next point, -1, 1. So the y value is 1. And if I multiply that by -3, I get -3. So instead of -1, 1, I get -1, -3. The next point, 0, 0. And if I multiply 0 by -3, I still just get 0, so it just stays the same. And then 1, 1, the y value is 1. If I multiply 1 by -3, I get -3. And it should just be a reflection of the points that we just got, since this graph is symmetric. But we'll do it anyway. 2, 4, the y value is 4, and if I multiply 4 by -3, I get -12, so it's way down here. And this is exactly what we should be getting, because we should know that when you multiply a function with a negative, it's going to reflect upside down over the x-axis. And since it was multiplied by a 3, it's vertically stretched. The points, the coordinates are now 3 times as far from the x-axis as they were before. So then the final step is to shift. And we already said what h and k are. We're going to shift 4 right. So that comes from here. The number that's added or subtracted with the x is the number that tells us whether or not we're going to go left or right. It's a horizontal shift, and you do the opposite. Since it's -4, we go in the positive direction, we go right 4. And we're also going to shift up 3, because there's this number here just by itself, and that's the vertical shift. So we're going to go up 3. So I'm just going to take each of these points and just move them over, the green points that I just got, move them to the right 4 and up 3. I'm going to start with, since those bottom ones are kind of off the graph, it's a little harder. I'm just going to start with 0, 0. So right 4, up 3 would be up here. I'm going to do the other 2 points. And then I'll do those bottom ones. Again, it's a little harder because they're off the graph. Okay. And there would be our final graph. This doesn't ask for domain and range, but we may as well write it because that's something that comes up a lot when we're graphing. Sometimes we're asked for domain or range. So domain for quadratics, for parabolas, for an x squared function, is always just going to be all real numbers. So we can just plug in any number for x, or if we look at the graph, it's just getting like wider and wider in the positive and negative x direction. The range, so those are where all the y values are. The range is the outputs. The y values go from negative infinity. So it goes to negative infinity, but then it stops here at 3. So for a range, I'm going to put from negative infinity to 3. And it includes 3. That's actually like touching the point 3, so I'm going to put a bracket. Okay, now we're going to talk about x cubed. So again, we're going to make a little table. We're going to sketch the parent function for x cubed. If I plug in, I can plug in negatives. So I'm just going to do the same thing, -1 or -2, -1, 0, 1, 2. I can cube all of these numbers. We can cube positives or negatives. And we want to include some positives and negatives so we get like both on the positive and negative side of the x-axis. We can see what the whole graph looks like. So if we take a -2 and cube it, that means -2 times -2 times -2, which is -8. If you multiply 3 negatives, you get a negative. Okay, then -1 cubed. -1 times -1 times -1, that's -1. So if you ever forget what the parent function looks like, just make a table and start plugging in points. 0 cubed is 0. If you cube 1, 1 times 1 times 1 is just 1. And if you cube 2, 2 times 2 times 2 is 8. And again, we could keep plugging in more numbers, but this gives us enough to see what shape we're looking for, what it looks like for the parent function. And then we're going to try a graph with transformations. So the transformations work the same way. It's you want to identify what the parent function is, and then you start with the A transformation, and then you shift after. Okay, so we're going to try graphing. This should be cubed, not squared. We don't want to do another quadratic. We want to do a cubic. So we're going to start with just the first step is to graph the parent function, which is just x cubed. So if you see the x cubed there, and that was supposed to be a cubed. So if you see the x cubed there, then that's what you're starting with. A is a half, by the way, which we'll get to when we get there. And then h is -2, because remember it's the opposite. We're going to be shifting to the left 2. And then k is -5. Okay, so I'm just copying the same points that we just graphed on the previous slide from the parent function. Just going to make it dashed because this is not my final graph. This is just what I'm starting with. Okay, second step is identify a. It's a half. It's the number being multiplied to the x cubed. And the way we do that transformation graphically is we multiply the y values on our points by a half. So that means we go to each coordinate and we multiply the y value in the coordinates by a half. I'm going to start with all the way to the left. -2, -8. The y value is -8, and if we multiply -8 by a half, we get -4. And then I'm just going to keep going toward the right. So -1, -1. The y value is -1, and if we multiply that by a half, we just get a half. 0 times 0 is still just 0. The next point, the y value is 1, and if we multiply 1 by a half, we get a half. And then 2, 8, the y value is 8, and if we multiply 8 by a half, we get 4. So when the a value is between 0 and 1, our function vertically compresses instead of stretches. It's half the distance away from the x-axis that it was before. It's compressed flatter vertically. And then we're going to do the shifting step. So step 3, because it was a +2 in the parentheses with the x, we shift left 2, and then the -5 means down 5. So I'm just going to take each of those green points and move them left 2, down 5. Okay, and then those red ones, I'm going to connect, and that's my final graph. Again, it doesn't ask for domain and range, but we may as well just go over that because we are sometimes asked it. So we could plug in any number for x. Domain is the x values. And also if we look at our graph, it's not restricted, it doesn't stop, it just keeps getting wider and wider. So all real numbers or -infinity to +infinity is the domain. And same thing for the range. We could get any output. If you look at the graph, it just keeps going up forever and down forever in the y direction. So -infinity to infinity. All right, we're going to try 2 more where we try to write the equation of the graph. Okay, so let's look at this first one on the left. It's clearly a parabola, which is x squared. So we want to I'm just going to write down that we know that this is x squared. Then it's upside down. It looks like it's been reflected over the x-axis. Normally x squared would just be pointing up like that, but -x squared points down, so it's going to have a negative in front of it. Okay, I'm actually going to start graphing just what the parent function looks like. So remember, these are our points for the x squared function. Okay, but they've been reflected upside down, so then they would end up down here. And then it looks like it's also been shifted to the left 3 and down 2, and now they're down here, but it's still not lining up with the red graph. But I can go ahead and write down what I've done so far. To go from the blue to the yellow, put a negative in front. We multiplied the function by negative. That makes it reflect over the x-axis. And then to go from yellow to green, I shifted the points to the left 3 and down 2. So far, I have negative x plus 3 would make it go to the left 3 squared, and down 2 would mean there's a -2 at the end. But again, it's still not lining up quite where the red one is, because so far we have this, And clearly that's not what the red one is. So then if I look at where the points actually are on the red one, it starts here. And the next point, instead of going over 1, down 1, it goes over 1 and then just down a bit. It's hard to tell. Maybe that's like a half or a third. So then I'm going to go to what the next point should be. So if I look at the green points, the next one is over 2, down 4. My curve is a little off, but the next coordinate is over 2, down 4. And then if I go to the red one, it's not over 2, down 4. It's over 2, just down 1. And basically it's a fourth of the way down for what the point should be. So instead of going over 2, down 4 like it would if there was no vertical compression, it's going over 2, down 1, which is a fourth as much as it should be. So the A value was negative 1/4. So my final equation should be negative, oops, I just put half, fourth, negative 1/4 x plus 3 squared minus 2. And I'm just going to put a little f of x in front. Okay, I'm going to try the next one. And that looks like a cubic shape. So x cubed looks like this. But it's not going up to the right and down to the left. It's actually going this way. So that means it was flipped over the x-axis. So it's negative x cubed. And it's not starting at 0, 0. So the parent function should just be at 0, 0. If it was negative, it looks like this. So this would be negative x cubed is where the points would be. Those blue points would be negative x cubed. But they're not there. It looks like it's shifted down. And they're actually here. And then the next point should be over 1, down 1. And it doesn't quite look like it's there. It looks a little further than over 1, down 1. In fact, it looks like it's over 1, down 2 instead, right here. And same thing the other way, it looks like it's to the right, the next coordinate is to the right one from that center point at 0, negative 4, to the, left one up 2. So these distances in the y direction are twice as much as what they should be if there was no vertical stretch at all. So the vertical stretch is 2. It's twice as far as what it should be in the y direction. And it's been, we said before, it's been shifted down 4. Not shifted to the left or right at all. So this one, I'm going to use a different letter. I'm going to put g of x. So it's negative. And then it was 2, it was vertically stretched by 2, not horizontally shifted at all, so just x cubed, but shifted down 4, so minus 4.